Today I'm going to solve the question, LeetCode question 981, time-based key value store. Design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. So we implement the time map class like this. We initialize the object, then we have a function set, a method set, which stores the key and the value at the which stores the key with the value at the given timestamp. Okay, so like if this is the key here, then its value would be like value at this timestamp. Okay. String get returns a value such that set was called previously. We don't have to worry about set it being empty. With timestamp previous less than or equal to timestamp. If there are multiple such values, it returns value associated with the largest timestamp previous value. If there are no values, it returns empty string. So what does this statement exactly mean? So let's say we have a key, A, okay, and its values were, B at timestamp 1, or let's say timestamp 11, and C at timestamp 12, okay? Actually, instead of 12, let's do it 13, okay? And what if we were tasked in finding value at timestamp 10? Well, it would return blank string because we want associated with the largest value timestamp previous, okay? So this would be timestamp previous, or sorry, return value sets as called previously with timestamp previous less than or equal to timestamp thermal. Associates the value with the largest timestamp previous. Okay. So now, obviously, where would this fit in? It would fit in right here. But there's no previous timestamp where we can reference in order to get the value, okay? So in that case, we return blank string. But if t is equal to 12, then of course that would fit in between here, and we return the largest previous timestamp. So in that case, or largest value, or the value at the largest previous timestamp. So in this case, it would be 11. Okay, so that's what this statement basically means. Okay. So what we can do is use a dictionary object to store the key and the value and timestamps. So how would it look like? This would be the key, this is string here. And the values here would be an array of tuples, and in these tuples, they would contain the timestamp, I guess the reverse of here, the timestamp and the value, okay? So that's how we would do set. If this key already exists in this dictionary for the object, then we would, if it already exists, then we just simply append to the existing array. But if it doesn't, then we create a new key here and have it set to initially with one tuple, which would be timestamp val. Okay, and get. How would we do get? So, for example, if we had a foo here, and obviously, let's follow the example here. So it would be like 1 bar and 4 bar 2. Okay. One thing to note: all the timestamps of set are strictly increasing. This is important. Okay, so that means they are basically in sorted order here. You don't have to worry about sorting them themselves. So it's basically in sorted order. So how will we do get? So what we can do is iterate through the list here one by one until we either reach the timestamp or reach the biggest previous timestamp if it's not here. Okay, so if we had like 3, if we were looking for value timestamp 3, obviously it's not here, so we return this. So we could iterate the array one by one by doing that, but there is a faster way. And remember, timestamp is strictly increasing. That means this is sorted. So to find something that is in a sorted array, we can use binary search. And this would be O log n time, which is better than our previous runtime of O of n time, which is what we would get if we were to iterate one by one. Okay, so that's how we would go about it. So if we want to look for, timestamp 1, value at timestamp 1, we would simply do a binary search and find it here. But what if it didn't exist? Okay, what if we want to find, timestamp 3, or I guess, 3 here, and it didn't exist here? So we would do regular binary search still. For example, if we did regular binary search, this would be our left, right, and this would be our mid pointer. And since 3 is greater than 1, we want to obviously search over here. So our new left pointer would be here, along with the right pointer. This still isn't 3, so what we do is, like in regular binary search, we decrease the search range by decreasing the right. And since left is greater than right, we stop binary search, but we see already that we are at the timestamp we want. Okay? We're already here, so what we want to do is return wherever right is. Return the value wherever this right pointer is. So that's how we do that. What about for another case? What about for, say, 5, at timestamp 5? So left pointer over here, right pointer here, our target timestamp is 5. So this would be the median. Obviously 5 is greater than 1, so we move our left pointer here. Okay? And this would be the median now. And since 5 is still greater than 4, what we do is move our left pointer here. But it's out of range now. Okay, our left is greater than right now, so our binary search stops. But notice right pointer is at the value we want, so we return the value here. Okay. And what about if we want to look for timestamp 0? Well, we simply return empty string, because remember, we want to search for the largest previous timestamp. And if 0 is supposed to be here, there is no largest previous timestamp, so return empty string. And that's how we're going to go about this problem. It would be take O of log n time to do all these operations here. Or O of log n time to do the get operation. For set, it should just be O of 1. And time mapping initialization, it should just be O of 1 operation. Okay, so now what we're going to do is first initialize the object. So we're going to do just a simple hash map here. And yeah, that's how we're basically going to initialize it. Pretty easy. And for set, we're going to first check if key not, let's start with this case, not in self.hash then basically add this key to our hash array, to our hash set, or dictionary as it's also called in Python. Key, and we're going to store a tuple, an array of tuples, where the first value is going to be timestamp, and second value is just going to be the value itself. And what if key is already in this hash map? Then we're going to get this array here. And then to this array append this new tuple. And then assign the value at this key to the updated array. Okay, pretty straightforward. Now for this get here. So what we're going to do is basically a binary search. So we have to put, or what we want to do actually first, just to fail safe, we want to check if key in self.hash. We want to check this edge case first, or if key not in self.hash, we want to check this edge case first, then just return empty string. There's nothing to return in this case. Else, key basically does exist. So what we're going to do is get the array of tuples associated with this key. Okay, and initialize our pointers for binary search. And this one, okay. And while left is less than or equal to right index, we're going to calculate the midpoint index. Left plus right 2, okay. And then we want to check if the timestamp so 0, I do 0 here because in this tuple timestamp is stored in the 0th index of this tuple. So if at this index this equals to our timestamp, then simply return the second part of this tuple, which is the time value. Or else, if AR mid 0, if that's less than timestamp, okay, so if like this is 5 and this is 6, then what we want to do is go towards the right. Mid plus 1. So you want to narrow our search range towards like the right. And now we do that by shifting this left corner to the right. Else you want to shift our search range to the left, so mid minus 1. Okay. And what if after all of this the exact timestamp doesn't exist in the array here? So what we're going to do is first check the case. What if that timestamp is really small? What if there's no previous timestamps before it? Then just return empty string. So if how do I want to go about this? So if timestamp is still less than right right at position 0. So if it's still smaller than our very first element. So example, if we have like 1, 4 as our timestamps and our given timestamp is 0, so left point will be here, right will be here. This is obviously midpoint, since this is smaller, right will be moved here. And since this is right will be here, yeah. So if we're looking for 0, our left pointer is here, right pointer is here. This is obviously the midpoint, and since 0 is less than the midpoint, we want to do a shift right over here. So right equals mid minus 1, so right is, okay. So return that, else we're just going to return our right 1. Okay. I think this looks right. Let me just check this logic one more time. So if we have 1, 4 and our target is 0, left here, right here. This is the midpoint. Since 0 is less than 1, we want to move our range here. So right equals mid minus 1 goes 0 minus 1. Okay. So I want to check if right less than 0 or. Okay. I think I should have covered this. Protects us from any out of bounds errors. Okay, let me try with the examples we have. Time stamp. Okay, I'm going to use these other test cases here. Okay, and I'll try submitting. Okay, great. Thanks for watching.